Welcome back, everybody, for another deep dive. This time, we're going to be talking about something that's got astronomers really, really excited.
Yeah.
We've got a galaxy. It's called JADES GSBZ 140. Oh,
That's a mouthful.
it is a mouthful.
Yeah.
But luckily, there's a great article about this.
Right.
Called "This Ancient Galaxy's Unexpected Chemistry Could Rewrite the Story of the Universe."
Yeah, and what's really fascinating about this galaxy is its age.
Okay.
So just imagine a universe that's only 2% of its current age.
Yeah.
So a mere 300 million years young.
Wow. Okay, so my brain needs like a minute to process that.
Right.
We're talking about a time when the universe was like just a baby.
Barely out of the cosmic crib.
Yeah, and we're already seeing a galaxy that seems like surprisingly grown up.
Right.
So how did they even find something this faint and this distant?
Yeah, so it's really like finding a single sequin on a dress that's miles away.
Oh, wow.
They were using the James Webb Space Telescope, or JWST, for this massive survey called JADES.
Okay.
The JWST Advanced Deep Extragalactic Survey. And they focused on a minuscule portion of the sky. Like, think about a grain of sand held at arm's length.
Oh, wow.
And that's where they stumbled upon this incredible galaxy.
So this JADES-GSZ 140, I'm picturing this tiny, faint little speck, right?
Yeah, actually, that's where the first surprise comes in.
Okay.
It's not a faint speck at all. It's actually remarkably bright.
Oh,
For its age, which suggests it's much more developed than anyone expected.
okay.
And this brightness hints at something even more intriguing.
Okay, now I'm really hooked.
No.
Tell me what's so intriguing about its brightness.
So it suggests a complex chemical composition.
Okay.
And by complex, I mean the presence of elements astronomers call metals.
Okay.
Now, when we say metals in astronomy, we're talking about any element heavier than helium.
Gotcha.
And these metals are formed within the fiery hearts of stars.
Okay, so this baby galaxy from the dawn of time has elements that should only come about after multiple generations of stars have lived and died.
Yeah.
Hold on, how does that even work?
Yeah, that's the million-dollar question, right? Astronomers were particularly surprised to find significant amounts of oxygen.
Okay.
And they used an instrument on JWST called MIRI, the mid-infrared instrument, to find that.
Okay.
And oxygen, believe it or not, is considered a metal in astronomy
Okay.
because it's created through a process called stellar nucleosynthesis,
Okay.
essentially the cooking of elements within stars.
So I'm trying to wrap my head around this.
Yeah.
It's like finding a bakery with fully baked cakes before ovens even existed.
Right.
Does this mean our understanding of the timeline for star formation is wrong?
It's certainly throwing a wrench into our existing models.
Okay.
For example, current models suggest that the first stars ignited a few 100 million years after the Big Bang.
Right.
This discovery implies it happened much faster,
Wow.
perhaps due to denser early matter or types of stars we haven't even imagined yet.
So this is turning our assumptions upside down.
Yeah.
This one galaxy is basically throwing us a cosmic curveball.
Yeah.
But wait, the article also mentions that finding this galaxy in such a tiny patch of sky could mean there are many more like it out there, right?
Exactly. Finding this galaxy in such a tiny sliver of the universe suggests that there could be a whole population of these early chemically rich galaxies hidden from our view.
Oh, wow.
It's like realizing the tiny ant you saw might be just the tip of a massive anthill.
Okay, this is getting seriously mind-blowing. We've got this ancient, unexpectedly developed galaxy that's messing with the timeline of the universe, and there might be a whole bunch of its siblings out there.
Yeah.
But before we get lost in this vast cosmic sea of early galaxies, let's take a step back and focus on the brilliant minds behind this discovery.
Sure.
The article specifically mentions the University of Arizona, right?
Yes. They've been leaders in infrared astronomy since the mid-1960s.
Wow.
Their expertise in this field has been instrumental, especially in building one of the key instruments on JWST,
Okay.
an IRCam, a near-infrared camera.
And I can't. Okay, what's so special about this camera?
Well, you see, observing incredibly distant objects like JWST Z140 requires us to look at the universe in infrared light.
Okay.
Think of it like this. The further away a galaxy is, the more its light gets stretched towards the red end of the spectrum, eventually entering the infrared range.
Okay.
And that's where NIRCam comes in. It allows us to capture this stretched out light, essentially seeing further back in time than ever before.
Wow. Okay.
Yeah.
So the University of Arizona has been pretty instrumental in providing us with the tools to like peer back into the universe's earliest chapters.
Yeah, they've really made a huge contribution to the field.
For sure. And you know what really fascinates me is just the fact that like we're alive at a time when these discoveries are even possible.
Yeah.
You know?
Right.
It's like we're holding a time machine in our hands.
It really is an incredible time for astronomy.
It is. And speaking of time machines, this discovery is like making us rethink the timeline of the early universe altogether.
Yeah, for sure.
Like we were saying earlier, JADES GSC 14-0, it seems to have a much more complex chemical composition than should even be possible for a galaxy its age.
Right.
It's like finding a sophisticated city in the middle of the Stone Age.
Exactly. The presence of oxygen, remember, is considered a metal in astronomy.
Right.
It suggests that stars were already forming, living out their life cycles, and ending in those dramatic supernova explosions
Right.
much earlier than we thought.
So this isn't just about this one galaxy. This is about pushing back the entire timeline for when star formation could have begun after the Big Bang.
Precisely.
Yeah.
Our current models suggest it took a few 100 million years for those first stars to ignite.
Right.
But JADES GSC 14-0 might have been churning out stars when the universe was just a baby, maybe even as young as 200 million years old.
That's just wild.
Yeah.
So it's like the universe was in a much bigger hurry to create stars than we initially thought.
It seems that way.
But hold on, if this galaxy formed so early and so quickly, does that mean it's just like a one-of-a-kind cosmic quirk? Or could there be more out there?
That's the question that has astronomers so excited.
Okay.
Remember, they only observed a tiny fraction of the sky with JWST.
Right.
Imagine searching for a specific grain of sand on an entire beach.
Oh.
That's the scale we're talking about.
Okay.
And they found this remarkable galaxy in that tiny, tiny sliver of the universe.
So you're saying this could be just the tip of the iceberg?
Yeah.
A hint that there's a whole hidden population of early chemically rich galaxies out there just waiting to be discovered.
Absolutely. And if that's the case, it would completely change our understanding of how the universe evolved from its simplest beginnings.
Wow.
Imagine our models of galaxy formation might be missing a crucial chapter, the part where galaxies were forming and evolving much faster than we thought possible.
You know, this is giving me a sense of like both awe and excitement.
Yeah.
Awe at the sheer scale and mystery of the universe.
Right.
And excitement at the potential for future discoveries, like who knows what else is lurking out there in the darkness, just waiting to challenge our assumptions.
Yeah, it's really exciting to think about.
It is, but, you know, all this talk about galaxies forming and stars exploding, it can feel a bit abstract and distant, right?
Sure, I understand.
Like, why should we care about what happened billions of years ago in a galaxy far, far away?
Right.
What does this have to do with us here on Earth?
That's a great question. And studying these early galaxies isn't just about satisfying our scientific curiosity. It's about tracing our own cosmic ancestry.
Okay.
Remember those metals we keep talking about? Well, the very atoms that make up our bodies, the planet we live on, everything we see around us, were forged in the fiery hearts of stars that lived and died billions of years ago.
Wow.
Possibly in galaxies just like JADES GSZ 14-0.
So we're all made of stardust, literally.
Literally. And by studying these early galaxies, we're essentially connecting our present to the universe's distant past. We're piecing together the story of how those very atoms came to be, how they eventually coalesced to form planets and eventually life as we know it.
I'm getting chills thinking about that. It's like we're part of this grand epic story that started billions of years ago with the Big Bang.
It is kind of amazing.
And it's a story that's still unfolding, and we're privileged to be witnessing it.
We really are.
It really is a humbling and awe-inspiring thought.
It is.
And speaking of the story unfolding, this discovery raises some very specific questions about our current models of galaxy formation.
Right.
Remember how surprised we were about the oxygen found in JADES GSC 15-0?
Yeah, that was a big one.
It's like the universe is telling us we've got it all wrong.
Yeah, it definitely challenges our assumptions.
So how are astrophysicists reacting to this? Are they like scrapping their models and starting from scratch?
Not quite. It's more like they're trying to figure out where the missing pieces of the puzzle go.
Okay.
They're looking for ways to explain how galaxies could form so early and evolve so quickly.
Okay.
For instance, they're exploring the idea that maybe the early universe had pockets of incredibly dense matter that could collapse and form stars at a much faster rate than we see today.
So maybe it's not that our models are completely wrong, but rather that they're missing some crucial ingredients that were present in the early universe.
Exactly. It's like baking a cake and realizing you forgot the baking powder.
Yeah.
The cake might still turn out edible, but it won't be as fluffy and delicious as it could have been.
I get it.
Yeah.
And that's where more observations and research come in, right?
Absolutely. The more we observe, the more data we gather, the better our models will become.
Right.
The James Webb Space Telescope is a game changer,
For sure.
but we need more more powerful telescopes, more innovative techniques, and more brilliant minds working on these problems.
It sounds like we're just at the beginning of a very exciting chapter in astronomy.
We are, and I, for one, can't wait to see what other surprises the universe has in store for us.
Wow. It feels like we've been on like a whirlwind tour of the early universe, and I'm not sure I want to come back down to Earth just yet.
Yeah, it's very mind-blowing stuff.
It is this whole idea that our current understanding of galaxy formation might be like a crucial chapter.
Yeah.
It's both exhilarating and like a little unsettling, isn't it?
It definitely is. It's a reminder that science is a constantly evolving process. You know, we're always learning, refining our understanding, and sometimes like completely overturning our assumptions.
Right.
And that's what makes it so exciting.
Yeah. You know, one thing that really struck me throughout this whole deep dive is just this idea that by studying these ancient galaxies, we're not just exploring the distant past, we're essentially looking at our own cosmic origins.
That's right. We've talked a lot about the surprising presence of oxygen in JADES GSZ 1400. But remember, it's not just oxygen, you know?
Right.
Every element heavier than helium, every metal, as astronomers call them, was created inside stars.
Yeah.
And those very atoms are the building blocks of everything we see around us, from the planets to the trees to us.
It's incredible to think that like the atoms in my hand were once part of a star that exploded billions of years ago.
Yeah.
Possibly in a galaxy like the one we've been discussing. It's like, it makes me feel connected to the universe in a way I never imagined.
It's a really profound realization.
It is. So where do we go from here? What are the next steps in unraveling the mysteries of the early universe and finding more galaxies like JADES GSZ 1400?
Well, the James Webb Space Telescope has given us this incredible glimpse into the early universe.
Right.
But it's just the beginning.
Okay.
We need more observations, more powerful telescopes, both on Earth and in space, to peer even further back in time.
And what about like the theoretical side of things?
Yeah.
Are there any promising avenues of research that could help explain how galaxies formed so early and evolved so rapidly?
Yeah, astrophysicists are exploring a whole range of fascinating possibilities. Some are revisiting the role of dark matter and dark energy in the early universe. Others are investigating the possibility of primordial black holes acting as seeds for early galaxy formation.
Wow.
It's a very dynamic field with new ideas and theories constantly emerging.
This whole deep dive has been a roller coaster of awe and wonder.
It has.
It's amazing to think that we're living in a time where we can make such incredible discoveries and challenge our fundamental understanding of the universe. You know,
It is a remarkable time.
what a time to be alive.
I couldn't agree more. And who knows what other mind-boggling discoveries await us in that vast expanse of the cosmos.
Right.
One thing's for certain, the universe will never cease to amaze us.
Well, this has been an incredible journey,
It has.
and I can't wait to see what other secrets the universe reveals to us in the future.
Me too.
Thanks for taking this deep dive with us.
My pleasure.
Keep looking up and never stop exploring.